Learn the secrets of success. Exclusive insights and information from the experts. Tag Radio. Ready to let your mind go wherever technology leads? Then tag, you're it. Tag Radio. Here today. Imagine tomorrow. Ever wonder how the Internet began? That in fact there may have been a single person that would be called the father of the Internet? The co-designer of TCP/IP protocols and basic architecture? A person at the moment of non-existence before existence? Virtual before reality? Possibility beyond imagination? To engineer the invisible into the most powerful technology ever to impact the human condition. Vinton G. Cerf, Vice President and Chief Internet Evangelist for Google. Greetings, everyone. It's Tuesday, October 2nd, 2007, and this is truly a very special edition of Tech Talk with Technology Association President Tino Mantella. This is Frank Baia serving as your guest host as the Tech Talk turns to the man widely known as the father of the Internet, Vinton Cerf. Vint has received the U.S. National Medal of Technology in 1997 and the 2004 ACM Alan M. Turnick Award, sometimes called the Nobel Prize for Computer Science. In November of 2005, he was awarded the Presidential Medal of Freedom, the highest civilian award given by the United States by its citizens. He serves as chairman of the board of Internet Corporation for Assigned Names and Numbers, ICANN, and was founding president of the Internet Society, a fellow of the IEEE, ACM, and American Association for the Advancement of Science, among many other prestigious academies, consortiums, and associations. Vinton G. Cerf, Chief Internet Evangelist for Google, and one of the world's leading innovators and thinkers at the forefront of a digital revolution that has transformed global commerce, communication, and entertainment. Vint, welcome to Tech Talk.
Well, thank you so much, Frank. I really appreciate the opportunity to join you today. I feel compelled, though, to make one observation. I'm not the father of the Internet because, first of all, Bob Kahn and I did this work together back in 1973, and it was based on the work of other people, including ourselves, that did the predecessor network called ARPANET. So, also, you never get to where the Internet is today without having tens of thousands, hundreds of thousands, maybe even millions of people contributing in one way or another. So really, this is a gigantic shared enterprise, and I'm just happy I was around early on to be part of it.
I think you're really describing the spark in a grass fire, and I think it is difficult to see where it started, but something had to begin. You know, let's talk. I've heard you talk about this before, and I've had the pleasure of seeing you making presentations, and you commented once that in a technology world, it's possible for everybody to be a winner. Talk a little bit about, the Internet now, 500 million users spread across a diverse number of users, North America, Asia. Give us a little insight about the impact of the users as far as their access is concerned.
Well, first of all, the numbers now look like they're in the order of almost 1.2 billion users. The largest single segment is in Asia, over 400 million users there. So it's a very significant change from the days when this was primarily a phenomenon in North America. The existence of that many users in so many different parts of the world has really transformed the face of the network. For one thing, the most interesting phenomenon is that as the network evolved, more and more the users have put their own information into the system as opposed to simply being consumers of a small number of sources of content. Now everyone is contributing in one way or another, whether it's blogging or websites or playing in multi-user games or putting up images in Flickr or any of the other various social networking environments like MySpace or Facebook or Orkut and the multi-user games like Second Life or World of Warcraft, just to name a few. So what we're really seeing is a massive collaboration among 1 billion people or more, with huge numbers of devices, programmable devices on the net. Right now, there are probably close to 500 million servers on the Internet today, probably an equal number of laptops, desktops, things of that sort, client-type machines. But also, increasingly, mobiles are part of the Internet environment. 2.5 billion of those. Not all of them are Internet-enabled, but a significant fraction are, and increasingly over time, I think they all will be. So we're starting to see the beginning of another transformation in the network environment where literally huge numbers of devices are on the network, probably more devices than there are people.
Now, again, to one of the questions I guess I'm posing in terms of the breakout, when you look at North America in comparison to Asia, and I know that there are experts that are talking about some of the markets, North America, Europe, not necessarily growing all that much in Internet users, while Asia and, of course, Africa, I guess, are wide open territory.
Well, Asia in particular, when you think about India and China being part of Asia, together with Malaysia and Indonesia and other very populous countries, the fraction of penetration there might be 10 or 12%, but the world's population that area represents is 56%. So as the penetration rate increases there, the number of people from that part of the world will grow very, very quickly. In the U.S., they're estimated, or North America really, they're estimated to be 230, 240 million users. That represents a 70% penetration rate. Our populations are not going to get hugely bigger, certainly nothing comparable to what we see in China and India. So we're already heavily penetrated. The European environment, which keeps changing because they keep adding countries, but there the penetration rates are not necessarily 70%, but maybe 40% or so. So one thing that you will see is an accelerating number of people coming from the Asian countries. They'll bring their culture, languages, styles of operation and interests into the Internet environment and color it pretty substantially. Africa, if I could just say, Africa is a huge challenge. There are a billion people living on the continent, but the communications infrastructure there continues to be spotty. And so getting Internet into a widespread use is hard. The thing which is most likely to happen there, as is happening in other parts of the world, is that mobile technology may be the first way in which these people have access to the Internet, and then later, as the infrastructure matures, they may end up with laptops and desktops like the rest of us.
Well, I want to go into that consumers becoming producers in a minute, but I guess probably, and also really, I don't think that we can avoid the concerns about policy, just consumer-friendly policy by government as it relates to the use of the distribution system or the platform for communication purposes. But before we go there, let's talk a little bit about IP version 4 and the fact of what we're facing in terms of version 6 and how is that going to be different and how is that going to impact us. I think you talk about 2011 as being a key point. You are the chair of ICANN, and so obviously you're right on top of the issue.
Well, first of all, it looks as if the ICANN allocations of IP addresses, which go out to the regional Internet registries, ARIN in the United States, the America's Regional Internet Registry, will be allocated, the last blocks will be allocated by ICANN somewhere around 2010 or 2011, which means that ultimately there will be no more available IPv4 addresses. There are only 4.3 billion unique ones. We can shield ourselves a little bit from running out by using NAT boxes, with network address translation boxes, which are already heavily in use, especially in cable modem settings or DSL settings from the telcos. Personal within a household, you might have one termination point, but you expand it by having a small network address translation box and firewall that leads you into the public net. IP version 6 has 340 trillion addresses. That's 3.4 times 10 to the 38th, which should be more than enough to last for quite a long time. The problem is that we're going to have to run v4 and v6 concurrently in the same network. And anytime you have two of something, then you have potential ambiguity. I have a v4 address and you don't. You're a v6 only thing. Can we talk to each other? The answer is, well, no. The two packet formats are not compatible. And so all the people running servers today, if they want to service a population which is getting v6 addresses, will have to run both v4 and v6 concurrently. There are a lot of issues associated with that concurrent operation. One of them has to do with network management. If things go wrong on one in v4 space, so to speak, is that mirrored in v6 space, or do you get errors from both? what about the host which is only running IPv6? How does it reach an IPv4 destination? Do you have to have application layer gateways to do that, and vice versa? What about connectivity? The current net is fully connected with IPv4, but we have these little islands of IPv6 capability, and they don't necessarily link up everywhere in IPv6 space. So there's going to have to be a concerted effort to make sure that the network is connected both in v4 and v6 protocol spaces. So there's a whole bunch of things that have to be done, and it's taken some long time since these protocols were standardized. At this point, I think there is software available for almost all the operating systems of interest. There is software available in the routers. The thing which is missing is that the ISPs haven't turned on the IPv6 capability very widely. And so what is needed now, I think, is for a concerted effort on the user side, and here I mean both businesses and consumers, to insist that they be able to get both v4 and v6 capability into the net. So
give us some insight in terms of, translate that from a global standpoint as far as, say, global commerce is concerned. Disruptive? Do we see a seamless transition? How is this going to impact,
well,
in a sense?
Seamless, I think, it would be a little optimistic. Undoubtedly, when you have both a new set of protocols that haven't been widely used yet, then there will be things that don't work right. So v6 will not be a completely trouble-free deployment. On the other hand, if you are doing the dual stack mechanism while we have both v4 and v6 capability everywhere, at least you might be able to recover from v6 problems by running v4. But ultimately, we have to rely on the v6 implementations being fully as reliable and debugged as the v4 ones have been.
I'm guessing in terms of telcos, obviously new appliances and new mobile appliances, but in the context of what we're talking about now, I'm guessing new product development, new browsers. I would think.
Well, actually, it's not a major difference to run v4 and v6. The functionality of the two classes of protocol are very, very similar. There are some features of v6 that aren't available in v4. Mobility is handled a little bit better, end-to-end security is handled a little bit better. But on the whole, it shouldn't be a big deal because most of the application level stuff is operating above the level of IP. Is not necessarily very sensitive at all to IP addresses. So the layer where you first encounter IP addresses is the TCP layer, which is underlying what runs the World Wide Web, HTTP. So the web is running mostly in terms of domain names, URLs, and the DNS layer, so to speak, and the binding to IP addresses is a lower level than that. So in theory, you should be able to run the applications regardless of whether it's v4 or v6.
Tell us a little bit, go into, if you will, a little bit about the changing from non-Latin characters and what that's going to do in terms of domain names.
No, that's another completely orthogonal activity that's going on in the domain name world. The idea there is to allow people to register domain names that contain non-Latin characters that might mean Cyrillic or Arabic or Hebrew or Urdu or Farsi or and Kanji or Chinese and so on. The intent is to allow people to have mnemonic places in the namespace of the Internet that are more familiar because of the character sets being used. It's turned out to be very difficult to do this in a way which is protective of security. What I'm getting at here is that many people, I'm sure, are familiar with the fishing and farming in the Internet today, in which people are fooled into thinking they're going to one place when they're actually going somewhere else. The characters, the richness of the symbols that are used in this extended character set. By the way, we're using something called Unicode, which is a widely adopted way of codifying an extremely large number of symbols that are used in different languages. This very, very large character set has to be mapped into a form which is useful and operable within the domain name system. So that's all been worked out, and it's, as we speak, being standardized in the Internet Engineering Task Force. But we went actually through a cycle about 4 years ago now, in 2003, when we thought we had it right, and then after some use was made, we discovered that it was easy for people to register strings which were confusing, because if you happened to be familiar with Latin characters and didn't realize that some of the Greek and Cyrillic characters looked the same but didn't mean the same thing and were distinguishable by the computers, then you could be fooled into going to a particular, what you thought was a particular destination, but it was spelled using characters from a different symbol set, even though the characters looked like Latin. And that led you, of course, to the wrong destination, and possibly someone on the other end asking you for usernames and passwords and creating all kinds of trouble. So we had to do some additional specification in order to limit the characters that are permitted to be used in these extended domain names.
I have to apologize because there's so much I want to talk about, and we have such brief time that if I interrupt you and it's being a little bit rude, it's because I'm trying to...
No, I absolutely understand.
Move it along to other subjects, because I'm sure our listeners are absolutely just enthralled with what you're talking about and want to hear more. But you had covered earlier about consumers becoming producers. I want to talk about hyperconnectivity, the idea that anything that computes is going to be able to communicate, and the idea of the two-way capability of the platform as it exists today. I know that you've expressed concerns that it kind of is more one way than the other. Go into a little bit about what you see in that area and what you see in the near future.
Well, the irony of broadband, at least in the United States, is that you, in fact, often get very asymmetric capabilities from the commercial suppliers. You get into this odd situation where you could receive very high-quality video, but you can't send it because the upload speeds are lower than the download speeds. It's technically feasible to do better than that, and in the business world, it's common that you buy symmetric capacity. A DS3 is running at 45 megabits a second in both directions, but many of the broadband offerings have an asymmetry to them. I think that because people are beginning to upload as much information as they download, particularly with videos and imagery and things of that kind, then we are going to have to adapt the Internet's interfaces in the commercial residential sectors anyway to be a lot more symmetric in order to accommodate that demand.
Talk a little bit, I heard you once talk about Wikipedia and the impact of a single word. I guess, this whole social networking phenomenon, trend, certainly a trend. I don't think it's a phenomenon. I think you probably talk about the societal impact in terms of the platform. Did you guys ever foresee that as you began to just distribute data, and go into a little bit about the impact and the power of contributing?
Well, to try to answer the question of did we see all this, of course, I think we didn't see the network as it currently exists. But without going into a lot of detail because of the lack of time, Bob and I and others who worked on the early Internet really did have some ideas of how it could evolve and what it would look like, because there were many nascent implementations of what we see today as far back as 30 years ago. It's just that they weren't nearly as widespread. And so the side effect of having 1 billion people interacting on the net was something we couldn't predict, and we're seeing some of the results. In terms of ability to contribute to the Internet, I think the barriers to contributing knowledge or information that you have dropped to zero. The Wikipedia analogy is that if you're looking at a paragraph of a Wikipedia and there's a one-word change that would make it better, you can make that change because it's designed to allow that. But you'd never publish a one-word book or a one-word paper. So, but you could upload a paper, and you could upload a book, and you could upload a movie if you wanted to. So and from the word to the page to the paragraph, to the paper to the book and the movie, the Internet absorbs all of those contributions, and the barrier to introducing them into the system is basically zero. And so this has really contributed to an enormous inpouring, I guess, of information into the Internet that's now shareable.
Now, obviously, in probably the distant future, but maybe even the foreseeable future, the amalgamation of information from different sources being organized by not only around time but around people. How do you guys at Google look at the intellectual ecosystem of the future?
Well, several things. First of all, our company focus is on organizing the world's information and making it accessible and useful. There are various organizing paradigms. Geographical indexing is very, very valuable, and you see Google Maps and Google Earth evidencing that. Organizing it around time is also valuable, as you see with typical email applications. And organizing around a personal focus, that is to say, who are my friends, my business associates, my family members, what do I know about them, what are they doing now, how can I interact with them as groups. Those are all part of the social networking phenomena that are emerging out of the Internet today. And I'm anticipating an increasing amount of that kind of interaction and looking for new ways of organizing information on axes other than the personal time or geography. It happens when people do searches in, for example, Google Scholar. They're trying to organize the information along particular concepts. So I'm looking for books about quantum communication, for example, or articles about it. That's organizing the information by concept, and that's a place where we're very interested in. What's missing is semantic understanding of the content of the net. Most of the search tools that are available today are very syntactic in their nature, matching character strings and things like that. The more we have an understanding of the meaning of things, I think the better we can sort the information to make it relevant, and that's an area of great interest and, of course, considerable research, not only at Google but elsewhere.
One of the fascinating things I heard you talk about was the unsustainable trends and sustainable trends. Maybe go into a little bit as we wrap up the interview. You talk about carbon emissions and obviously poverty as far as unsustainable. Cover a couple of those if you can.
Well, the things that are not sustainable, as I see it, and these are ideas that I didn't make up, but others have drawn to my attention, but certainly the cost of health care in the United States is an example of an unsustainable trend. The continued emission of carbons is an unsustainable trend. The dependence on oil is an unsustainable trend in the long term because we'll run out of it after a while. In fact, the fishing rate of pulling fish out of the ocean is another unsustainable trend because it's so dramatic that it's impacting on the survival of certain species. So these are all things that really, they tell you that you can predict something is going to have to change in the future because the trend isn't sustainable. Then the trick is figuring out, well, what will the outcome be, or what choices will there be for possible alternative futures. There are some trends that are sustainable, and I think some of them include increasing capacity of networks, increasing capacity of computers, increasing capacity of storage. All of those things have continued along the Moore's Law line, and they will probably continue.
Well, and decreasing cost of everything as well.
Precisely, or at least of many of the high-tech technologies because of either competition or learning curve where we learn how to make things cheaper and cheaper. We haven't even begun to crack the barrier of nanotechnologies, or I shouldn't call it barrier, but the opportunities of nanotechnologies where things could be made smaller and smaller and cheaper, possibly self-organizing. Maybe someday computers will grow on trees, literally, because they'll be organized by certain DNA processes. That would be pretty amazing.
Well, I mean, I've heard you talk about transparent technology. Other experts talk about it. The elimination of I guess, time as far as it relates to communicating, and the fact that you don't want to have to deal with time in establishing the contact. You want to be using it for direct communication. And I guess one of the things that we deal with all the time in this new reality is the export of labor and not the export of people. Certainly, one of the reasons I wanted to bring up this trend aspect is that with each negative and with each positive, surely there's incredible opportunities in terms of innovation.
Well, in almost every circumstance that I can think of, when the economics change in some sufficiently dramatic way, then opportunities open up, and threats as well. Business models that used to make sense because they were based on certain cost structures no longer make sense. That's why voice over the Internet may in fact supplant the traditional telephone services because it's less expensive literally to produce. It's just another thing you do on the net. You have to rethink your business models, and I think television is going to be like that too. I think television as an industry may have to rethink its models because the economics of downloading and playing back video are so different than they were even 5 years ago.
This is a little bit of my thinking in terms of engaging the now versus what's next. The idea of thickness rather than moving forward, getting more out of something and making it more dynamic in terms of the layers and tentacles of it. I guess with all of the technologies, all of the communication, especially with hyperconnectivity, engaging the moment is seemingly going to be something that we'll understand. Is that something that you can relate to in terms of what we've been talking about?
I think so, although there's a very odd thing going on. I was thinking of, as you were describing this, I was thinking of what some people think video on demand is, and many of them think that means immediate playback of a video in streaming video. And I'm sitting here thinking about Netflix and the fact that people go online, place orders, and then they show up in the mailbox a couple of days later. But the convenience of it all and the cost has driven that to be quite a successful business. The other side of the coin is the super high-speed access to the net, which you often get elsewhere in Japan, Korea, and Singapore, and so on, Stockholm, where you get gigabit per second service at prices that are consumer or affordable. You can download a video in a few tens of seconds, and an hour's worth or 2 hours worth in a few tens of seconds, and then play it back whenever you want to. That is a major change in the posture of the video medium, and I think it also opens up huge advertising opportunities that are more deeply under the control of consumers than the traditional kinds of advertising have been. Google has discovered that that's a very valuable style of interaction, something that attracts the consumers who don't have to look at anything they didn't click on. And the advertisers like it because the only people that ever look at their ads are people who are already interested in them.
That's the amazing part that I'm both challenged and frustrated by in terms of how do you even think about next in terms of what I'm saying here is engaging the now. I think Google is kind of addressing that, isn't it? Aren't your researchers looking at, this instant moment of connectivity that allows you to know at the time that you need to know and follow the path without really having to do anything more than connect to the Internet?
We would like to think that if we do our jobs well, that when you need a piece of information, we'll be able to supply it to you, and it's exactly what you were looking for. But in terms of looking towards the future, I think many of us are still trying to do that, even though looking beyond 10 years is almost impossible. The notion of collaboration has become very, very important, at least in Google's view. And so finding technologies that allow people to work together and share content, share information has been important to us. And, of course, I still have my favorite development program, which is not at Google. It's the Jet Propulsion Lab with the extension of the Internet to operate across the solar system.
I was going to ask you about the interplanetary Internet. We're running out of time.
The interplanetary network is a very good example of something that is very long-term. First, it's taken 10 years to get the designs done and to convince people that it's working the way it should, and then it's going to take many years to deploy the components, because many of the destinations are literally years away in terms of spaceflight. So it will take decades for this backbone to accrete over time. And so in some sense, that particular effort is contemplating many decades ahead, and it was driven in part by asking, well, what do we need 100 years from now? What should we start working on now so it will be available then? And the interplanetary backbone is one example of that.
What I have to say comes to mind, because I know you've done some work with the Jet Propulsion Laboratory in this area, and also you've also done some science fiction work with Roddenberry. And you kind of think, is Roddenberry the student or the teacher? That.
Well, I'm a science fiction fan, and I found it very stimulating to see what people speculate about might be possible. I prefer the kind of science fiction that has some roots in real physics and the real world, but it's extrapolating to things that we don't quite know how to do, but might conceivably be achievable. So I'm quite fascinated by the technologies of quantum communication, for example, which appear to have the possibility of zero delay over unlimited distances. Now that would make for a heck of an interesting networking technology.
Well, beam me up, Scotty, right? Yeah, it's going to happen. I'm afraid, or not afraid. We have to be fearless in going into the future. Listen, we've been visiting with Vinton G. Cerf, and Vin, thank you so much, Chief Internet Evangelist for Google. Thanks again for joining us on Tech Talk. Obviously intriguing, stimulating, informative, and really just not enough time to go over it all. Maybe you'll give us a chance to get together again.
I look forward to that very much, Frank.
Thanks, man.
Okay, bye-bye for now.